Hello. Hello and welcome to this 43rd set of questions on polynomials and quadratic equations. In this video, we will solve question number 421 to 430. At the end of video, I will show how we can get the PDF. So question 421 says that, and one more thing, when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So question 421 says that if x is in the set of integers, find the integral values of m satisfying the equation x minus 5 into x plus m plus 2 is equal to 0. So x and m are both integers because we have let x is in set of integers. So both integers, therefore x minus 5 and x plus m will also be integers. So our given equation is x minus 5 into x plus m is equal to minus 2. So we let x minus 5 is equal to 1 and x plus m is equal to minus 2. Minus is missing here. So you see it is minus 2. So there can be only two factors, 1 and 2 here. And one can be positive, one can be negative. So we will have four cases. 1 minus 2, 2 minus 1, minus 1 2 and minus 2 1. So in all four cases we have got two possible values of m, that is minus 8 and minus 2. So you can simply substitute and solve the equation for yourself. Question 422 says that find all the positive solutions. A is missing here. All the positive solutions of the system of equations x to the power x plus y is equal to y to the power n and y to the power x plus y is equal to x to the power 2n into y to the power n, where n is greater than 0. So we have the first equation here. We multiply this with the y to, oh sorry, my mistake. We multiply both the equations. So we get xy to the power x plus y is equal to xy to the power 2 to the power n. So x plus y is not equal to 2n, where xy is not equal to 1. Okay, because if xy is 1, then both will be 1 irrespective of x and y or n. So we have that, which implies that x square is equal to y. Then x plus x square is equal to 2n. So we have got x is equal to minus 1 plus minus square root of 1 plus 8n by 2. But x is greater than 0. Okay. Alright. So x is greater than 0. So x is minus 1 plus square root of 1 plus 8n by 2. That means y is equal to x square, that is 1 plus 4n minus square root of 1 plus 8n by 2. Now we come to question number 423. The question is solve the equation 144 to the power mod x minus 2 into 12 to the power mod x plus a is equal to 0 for every value of the parameter a. So we let y is equal to 12 to the power mod x, which makes the equation y square minus 2y plus a is equal to 0. So y is equal to 1 plus minus square root of 1 minus a. That is mod x is equal to log of 1 plus square root of 1 minus a by with base 12. Now in this case, y is equal to 1 minus the square root of 1 minus a has to be rejected as y is greater than 1. So you see, if we look at this, y has to be greater than 1 here. Okay, the reason is, if it is less than 1, then with base 12 it will be negative. On left hand side it is a modulus, so this has to be positive. 1 plus square root of 1 minus a should be positive. But also, the square root of 1 minus a has to be real. That means a is less than or equal to 1. And for the log to be defined, this 1 plus square root of 1 minus a should be greater than 0. So based on these conditions, we have x is equal to plus minus log of 1 plus square root of 1 minus a with base 12. Question 424 says that if m and n are odd integers, show that the equation x square plus 2mx plus 2m is equal to 0 cannot have rational roots. So what we do here is we put m is equal to 2p plus 1 and n is equal to 2q plus 1. Then our discriminant becomes 4 into 2p plus 1 whole square minus 8 into 2q plus 1, which will be an even number because 4 is multiplied here and 8 is multiplied here. It is an even number. Now if d is a perfect square, then it has to be perfect square of an even number. Let that number be 2r. I think we have solved this question, but in any case. So 4r square is equal to 4 into 2p plus 1 whole square minus 8 into 2q plus 1. We bring everything to one side concerning p and r and 2q on one side. We get 2 into 2q plus 1 is equal to 2p plus 1 minus r into 2p plus 1 plus r. Now if you see left hand side, it is an even number because it is multiplied with 2. So left hand side is even. And right hand side is even number, which is not possible because our if r is odd number, then right hand side is a product of two even numbers. Okay. Let 2p plus 1 minus r is equal to 2k and 2p plus 1 plus r is equal to 2l. Okay. So let me see this. Okay. There is some confusion here. So left hand side is even number. Okay. Now if left hand side is even, we look at the right hand side. R has to be odd to make both even. That's what we have let here. If R is odd, then these two become even. So 2 into 2 cube plus 1 is equal to 4kl from the assumption here, which is an odd number. Alright. So now if you see, this 4kl becomes an even number here if R is odd. 2 cube plus 1 having equality to even number 2kl. If you see this, 2 cube plus 1 will become 2kl. So 2 cube plus 1 is odd and 2kl is even, which is not possible. Therefore, in the given conditions, the equation cannot have rational roots. Question 425 says that if f of x is equal to ax cubed plus bx square plus cx plus d has local extrema at 2 points of opposite sign, then prove that the roots of the equation x square plus bx plus c is equal to 0 are real and distinct. So this requires a bit of calculus. You can skip this question if you have not studied calculus. So to find out the local extrema, we differentiate the given function f of x, which becomes f dash x is equal to 3x square plus 2bx plus c is equal to 0. Now we let one of these points be alpha and the second would be minus alpha. Okay, let's see this question. Yeah, 2 points of opposite signs, so alpha and minus alpha. Now sum of these roots would be alpha minus alpha is equal to minus 2b by 3a, which implies b is equal to 0. And products of root would be minus alpha square is equal to c by 3a. But since roots are opposite in equation in sign, this should be sign, it implies that a and c have opposite signs. Okay. So we now find b square minus 4ac, which gives us minus 4ac. Now a and c are of opposite signs, therefore this will become positive, which will be greater than 0. And therefore roots of x square plus bx plus c will have real and distinct roots. Question 426 says that if a, b belongs to the set of real numbers, b is not equal to 0, prove that the roots of the quadratic equation x minus a into ax minus 1 divided by x square minus 1 is equal to b can never be equal. So we let, no, we don't let, we are given that x minus a into x minus 1 by x square minus 1 is equal to b. So bring everything to one side. We bring everything to one side. We get a minus b into x square minus 1 plus a square into x plus a plus b. Now if you look at its discriminant, it becomes 1 plus a square whole square minus a square plus b square, which is equal to 1 plus a square plus a to the power 4 plus b square. Now if you see, a and b are in the set of real numbers. Therefore, this entire thing, which is of the form of even squares and plus 1, will be greater than 0. Okay, it will not be less than 0 because b is not equal to 0. So all these 8 terms, a square to the power 4b square, will be positive because they are real numbers. And this one ensures that it is greater than 0. Therefore, roots can never be equal. Question 427 says that if n and r are in the set of positive integers such that r is less than n, then show that the roots of the quadratic equation cnr x square plus 2cnr plus 1 x plus cnr plus 2 is equal to 0 are real. So we are given that equation, so we let d to be the discriminant, so this left is shouldn't be here. So it becomes 4 into cn r plus 1 whole square. Okay, the square is missing here. It is typing issue. Minus, that is the square of the middle coefficient, minus 4 into cnr into cnr plus 2, which will be greater than 0. Because all these are real numbers, these combinations would be real numbers. So we expand this, we get n factorial divided by r plus 1 factorial minus n minus r minus 1, this should be 1, whole square, minus n factorial by r factorial n minus r factorial dot n factorial by r plus 2 factorial n minus r minus 2 factorial. And then we solve this, we arrive at the result that n minus 1 is greater than 0. So from given condition, minimum value of n is 4, hence above equation is true, proving that roots are real. Okay. Now we come to, so the question is, how do we know that minimum value of n is 4? So that should be a valid question. Now if you look at this equation, these are positive numbers, okay? So r is given as less than n. So here, for the third term to be valid, r plus 2 would be 3. And then if r is 1, okay? If r plus 2, if you see, if r is 1, then this becomes 3, and then n becomes 4. Otherwise, it wouldn't work. Alright? So you can take up different examples. Say for here, r is in set of positive numbers, you put 1. Then n should be at least 1. Here, and r is less than n, so n should be at least 2 here. Okay? If r is 1, then n should be at least 2 here. And here r is increased by 1, so n should be at least 3. And for this, it should be at least 4. So that's how we know that the minimum value of n is 1. Now we come to question 428. If a, b, c are rational, show that the roots of the equation abc square x square plus 3a square cx plus b square cx minus 6a square minus ab plus 2b square is equal to 0 are rational. So we look at the discriminant, and the discriminant upon evaluation comes out to be c square into 3a square minus b square plus 4ab whole square, which is a perfect square, and therefore roots will be rational because abc are given as rational. Next question is, that is question 429. If the roots of the equation ax square plus bx plus c is equal to 0 be in the ratio m is to n, prove that square root of m by n plus square root of n by m plus b by square root of ac is equal to 0. So what we are given is m by n plus square root of m by n plus square root of n by m plus b by square root of ac is equal to 0. So our left hand side becomes alpha by beta plus beta by alpha plus b by square root of ac, because it is given that alpha beta are the roots, then they are in the ratio m is to n. So we take LCM, we get alpha plus beta by square root of alpha beta plus b by square root of ac. Now alpha plus beta is equal to minus b by a, and alpha beta is c by a. So upon simplification, you find this sum is 0. Now we come to the last question of this set. Question 430 says that if one root of the equation x square plus x into f of a plus a is equal to 0 is equal to the third power of the other, Determine, there should be E, determine the function f of x. So we let alpha to be the one root, then the second root will be alpha cube, because that's what our given condition is, that one root is equal to the third power of the other. Now we take product of the root, alpha 4 is equal to a. So alpha is equal to a to the power 1 by 4. Now sum of roots is alpha plus alpha cube, that is minus f of a. So f of a is equal to minus a to the power 1 by 4 minus a to the power 3 by 4. Therefore, the general equation in x would be f of x is equal to minus x to the power 1 by 4 minus x to the power 3 by 4. That is what we had to determine, that is the function f of x. So with this, we come to the end of 43rd set of problems, and I hope that you are enjoying these problems and videos. If you have any questions, let me know. As you have seen that there are lots of typing problems in this particular set, I'll ensure that these are corrected and I will upload the PDF. And about how to download the PDF, the link is in the description. The other way would be that you come to my website ashtavatru.org and you click on the second link. You can download the PDF. By observing the date, you will know whether you have a new PDF, if you have an older PDF. The last upload, as you can see, is on 27th March 2026. You can also download my trigonometry book, which is complete. And once I'll start trigonometry, I'll refer to this PDF. So thanks a lot for watching the videos. I wish you all the luck in your studies and exams. I'll see you in the next video. Stay tuned for the next video. So thank you. Enjoy.